Hello everyone, in this video I'm going to show you how you can solve systems of equations where some of those systems involve quadratics. And it really doesn't change anything at all. You can solve it the same ways that we did before, and the ways that we solved them before, where we can graph them to find the intersections. This is my favorite way to do it. We can use substitution to solve for the variable. We can use elimination, and we can plug in numbers. Plugging in random numbers to find out when the two equations are equal is actually like the worst way to do it. So let's not do that. If we use elimination, it's kind of difficult. You'll learn a really good way to do this later. So this is useful in college, but it's not that simple to do. It takes some time. Substitution is the straightforward approach. And finding intersections is the easiest way to solve systems of equations. So just to give you like a quick sketch of how we're going to do this. I have my y-axis, I have my x-axis. My first one's a parabola. It's not just a regular parabola, but we have the number 2 in front. The number 2 in front means I'm going to draw a skinny parabola because the parent function was multiplied by 2, so every y value on the table is twice as large as it normally would have been. And so that things match up, I'm going to change this from the x-axis. Because my equation has t, let's make that the t-axis. My second equation is y equals 72. So that means somewhere on the y-axis, we're going to have the number 72. We're going to have a line going through that 72. This is y equals 72. And it's going to cross my parabola in 2 spots. So just by looking at the picture, we can see that there are 2 solutions. From this sketch, because I didn't really make a scale, you can't see what those solutions are, but if we open up a calculator, we can see what the solutions are. The first equation was y equals 2x squared. Second equation was y equals 72. So you would have been down here at the origin. I'm using Desmos, the Desmos app, graphing calculator. I just typed in y equals 2x squared, y equals 72, and it comes up with this picture. If I follow the picture up, because our quick sketch said that the answer was going to be at 72 for y, if we go to 72 to the left, and we touch, we can see that the solution is negative 6, 72. And the second solution is 672. So my 2 solutions are 672, negative 672. Let's go ahead and put those back on my graph. Negative 6, 72, 6, 72, and that would be the answer to the question. But if we want to do this with substitution, both solve for y, then we are allowed to set them equal to each other. So y is equal to 2x squared, and y is also equal to 72. If these 2 things are true, then we don't have to worry about this part. We only need to worry about this part and solve for x. Well, it should be t, but it's the same thing. It's a variable. We're solving for the variable. So let's divide by 2, x squared equals 36, square root, x equals, there are 2 solutions. To get square root 36, you could either square negative 6, or you could square positive 6. And then we would go back to the equations, and we would plug it in. It'd be the easiest to plug in here. Plug in for x, because in y equals 72, there's no space to put x, so all we can do is say that y is equal to 72. So then the x is negative 6, and the y is 72. The other x is positive 6, and the other y is still 72. And then that's it, we solved it. Let's do another example. 3x squared plus 2x minus 4, that's equal to y. And y is also equal to 5b squared minus 10. If I make a quick sketch of this graph, let's just approximate that first one. This is the y-intercept. And then we have some things going on the left over there. There's a times 3, a plus 2x, so that's going to make this graph a bit skinnier than the parent function because we're multiplying by scale factors. But we know that the y-intercept is going to be at negative 4. Oh, I'm erasing. Intercept, negative 4. It's going to be that y-intercept. And I think it'll be maybe like that. It's just a sketch. I'll make a better one, like this. Let's pretend that's it. The second one, 5b squared minus 10. This one's y-intercept. It's going to be at negative 10. At negative 10, this second parabola is going to touch the y-axis. And since the second one's multiplying by 5, it's going to be even skinnier than the top one. So I think there's probably going to be 2 solutions. This is just for my quick sketch. At the y and the x, this is the negative y, this is the positive y. For y and x, I think they're going to touch in 2 spaces somewhere. But to find out exactly where, the easiest thing to do, let me change this to an x. In this class, it's not really okay. I should pay more attention to these variables. It's just, I know what I'm going to do with them, so I'm pretending that they're all the same variable. Okay, let's graph it. 3x squared plus 2x minus 4. Let's clear these ones. Y equals 3x squared plus 2x minus 4. Let me bring this back down to the origin. Y equals 3x squared plus 2x minus 4. And then the second equation, y equals 5x squared minus 10. Look at that. My first sketch was pretty accurate. The scaling was a little bit off, but it was shifted slightly to the left, and it does have the right side touching the negative 4. And the second one is centered around the y-axis, and it touches at negative 10. We can see that there's a solution on the left, and if I touch it, it's at negative 1.303, comma, negative 1.514. And if I scroll up and I touch, I can see that my second solution is at 2.303, comma, 16.514. So let me scroll out so that way I can see both of these solutions on the same screen. If I touch, it already highlights, Desmos.com already highlights the important parts of the graph. And those are the 2 points. Negative 1.303, 514. Let me see if I can copy this. Nope, can't. Negative 1.303. So this is negative 1.303, comma, negative 5.14. 514. 514. And this one was 2.303, comma, 16.514. And that will be our second system of equations. Whenever you're graphing these, you should definitely make your graphs look better than mine, but I'm just doing it really quick to show you that the sketch can help you get the general idea, but you do need to go to a graphing app to get the perfect picture, the clear picture. If you wanted to solve this using substitution, then once again we would set the two equations equal to each other. Y equals 3x squared plus 2x minus 4 equals 5x squared minus 10. Since 5 is the bigger coefficient, I'm going to move this side to the right. Minus 3x squared minus 2x plus 4. Okay, so that's going to give me 0 on the left. 0 equals 2x squared minus 2x minus 6. Let's divide all this by 2 to get x squared minus x minus 3 equals 0. Let's see if I can factor that. A negative 3, a minus 1. No. There's no way you can multiply to get negative 3 and add to get negative 1. So that means we have to use the quadratic formula. X equals negative b plus or minus square root b squared minus 4ac divided by 2a. X equals 1 plus or minus square root of 1 plus 12. 4 times negative 3. Well, negative 4 times negative 3 is 12. And the two negatives make it a positive. Divided by 2 times 1. So that's 2 equals 1 plus or minus square root of 13 plus or minus square root of 13 divided by 2. And that's going to be some ugly solutions because the square root of 13, well, let's go back to the calculator. Let's get square root of 13. It's 3.605. So that's 1 plus or minus 3.605 divided by 2. And those are going to be your answers for x. So that's where these parts came from. And that's ugly. And that's a lot of work. We had to use the quadratic formula. Sometimes you will have to do that. You will not get the choice every time. But graphing is the easiest way to answer these questions, a system of equations. I'll do one last example.